In this lesson, we're going to solve the equations by taking square roots. First thing we want to do is we want to isolate the expression that has a squared term. So we want to isolate the x minus 2 squared. In order to do so, we're going to need to subtract, do the inverse of positive 3 and subtract 3 from both sides of the equation. And what we're going to be left with is x minus 2 squared equals 9. Now this is the same thing as what we did the last lesson. Right? X squared equals 9. Remember what we did is we took the square root to both sides and we got x equals positive 3 and negative 3. Well, x minus x squared is the same thing as x minus 0 squared, right? Because what is x minus 0? X minus 0 is just x. So we just rewrite x minus 0 squared as x squared. So we do the same thing for this problem here. X minus 2 squared equals 9. We're going to take the square root to both sides. When we do that, the square disappears, right? Because there's a invisible 2 out here that cancels out with this exponent. And we're left with x minus 2 equals, remember the square root of 9 is 3, and x and negative 3. We could solve this equation by adding 2 to both sides, and we get x equals 5. Add 2 to both sides here, and we get x equals negative 3 plus 2, which is negative 1. So if we wrote our solution in set notation, it'd be 5 comma negative 1. Let's do the same thing for number 3. Again, we want to isolate this x plus 7 squared, so we need to subtract the 13. Do the inverse of plus 13, which is subtract 13. Subtract 13 from both sides. And we're left with x plus 7 squared equals 64. Take the square root to both sides. The square root of 64 is positive 8 and negative 8. So this 2 and this 2 will cancel out, and we're left with x plus 7 equals plus 8, and x plus 7 is equal to negative 8. Subtract 7 from both sides, and you get x equals 1. Subtract 7 from both sides here. Negative 8 minus 7 is negative 15. So in set notation, it'd be positive 1 and negative 15. So this is our solution for number 3, and this is our solution for number 1. For number 5, we want to get the squared term by itself again. So we want to move the negative 8 and the positive 6. First, we're going to move the negative 8 by adding 8 to both sides to the equation. When we do so, we bring down the 6k squared. The negative 8 and positive 8 cancel out, and 592 plus 8 is 600. We do the inverse of multiplication. 6 times k squared. The inverse of multiplication is division. Divided by 6. And we're left with k squared equals 100. If we take the square root to both sides of the equation, k will equal plus 10 and minus 10. Or if you write it in set notation, you can write it as positive 10 and negative 10. Let's go and try number 7. Again, we want to get v squared by itself, so we first want to move the minus 2 and then the positive 3. To get rid of the minus 2, we're going to add 2 to both sides. And we're left with 3v squared equals 27. Divide by 3, and you're left with v squared equals positive 9. At this point, we have isolated our squared term, so we could take the square root of both sides and give v equals positive 3 and negative 3. Again, if we wrote it in set notation, it'd be written as positive 3 and negative 3.